Hello. In this section of trigonometry, we will be verifying or proving identities. Identities are basically equations. You're showing that the one side of the equation is equal to the other side of the equation. In other words, identically the same. Now, the first thing you have to do before you can prove any identities is to know by heart the fundamental identities. So this first page of your study guide lists all the identities that you should know already, but we'll just talk about them briefly. You should know the reciprocal identities, and by the way, every one of these could be flipped so that you could also say, looking at the very first one, you could say that the sine of theta equals 1 over the cosecant of theta. So if two numbers are reciprocals, one is 1 over the other, and it doesn't matter which one comes first. That could be done for each one. And then you have the quotient identities. We've learned these all as on the unit circle as sine being y and cosine being x. But you also had to learn for tangent that the tangent is the sine over the cosine, which really is the y over the x, and the cotangent is the cosine over the sine. And I'm just showing here on the right that you, knowing your rules of complex fractions, you could prove this to yourself, that 1 over the tangent is 1 over the sine over the cosine, and then you would take the fraction in the numerator, which is 1 over 1, and then multiply it by the reciprocal of the denominator, and that would give you cosine over sine. So you know those already. Then also you know the odd and the even identities. In other words, you may never leave a negative angle inside of a trig function. So some of you will just memorize that the cosine and the secant being the reciprocal of the cosine, are the ones where the negative is dropped, and all the other ones, the negative comes outside. Now you could, depending on how good you are with your unit circle, and remembering that the x-coordinate is the cosine and the y-coordinate is the sine, you could, as a memory aid, think of the unit circle and notice that when the angle, which is theta, theta is the angle, when the angle is positive from 0 to pi over 2, and when the angle is negative from 0 to negative pi over 2, whether you're going in the positive or the negative direction, the cosines are all positive on that side, the x's are all positive on that side, and everything else, the negative comes out. Now the Pythagorean identities are the last group. You have already memorized the sine squared plus cosine squared equals 1. You will need to use these in different forms. So you need to be familiar with the sine squared being 1 minus the cosine squared, because you just subtract the cosine squared from both sides, and the cosine squared being 1 minus the sine squared. Once again, subtract the sine from both sides. Now, if you haven't learned the other two identities so far, now is the time to learn them. But you can always derive them yourself by taking the original sine squared plus cosine squared equals 1 and dividing. Doesn't matter which you do first. You can divide everything by sine squared, and then if you look at each one of them, sine squared over sine squared is 1, plus, remembering the previous page, cosine squared over sine squared is cotangent squared, and then 1 over sine squared is cosecant squared. So there you have your second Pythagorean identity, and that of course could be in any form, so you have to be ready for any of the forms. This is the main one, so we'll box that. And then you also have 1 equals cosine squared of theta minus cotangent squared of theta, or you could subtract the 1 from both sides and get cotangent squared of theta equals cosecant squared of theta minus 1. Now, I always, because my memory's bad, I always derive these when I'm starting out and then just keep it beside me, because sometimes it's hard to remember where the 1 goes and which is subtracted from which. And then you have the other set. Sine squared over cosine squared is tangent squared of theta. Of course, so cosine squared over cosine squared, oops, I meant to write a plus there. Plus, and 1 equals 1 over cosine squared of theta, which is secant squared of theta. And there's your second Pythagorean identity. And of course, that comes in two other forms also. Subtract the 1 from both sides. And then also you could subtract the tangent squared from both sides. And 1 equals secant squared theta minus tangent squared. And I advise that every time you sit down to do a homework, you write down these by memory and deriving them quickly for yourselves, at least the 3 major ones.